7.6 Using descriptors. We're going to see how to use descriptors to run code when an attribute is read, written, or deleted. We're going to see how to use the property decorator to create simple descriptors. And we're going to make a more complex descriptor class that handles network interactions and does other complex behaviors. Reading and writing variables is one of the most fundamental aspects of programming. Python's descriptors let us alter how it works. A descriptor is an object that is stored in a class and controls what it means to get, set, and delete a specific single attribute for any instance of that class. If we want that sort of control over multiple attributes, we just add a descriptor to the class for each attribute we want to control. Python's built-in property decorator provides a simple way to create a descriptor. The first foo method we wrote here tells Python how to figure out the value of an attribute called foo, which in this case just means fetching it from another attribute and printing it the value. The later two foo methods are decorated to make them into the setter and deleter for the foo attribute, which means that assigning a value to foo actually means calling the setter method, and deleting the foo attribute actually means calling the deleter method. Both methods are optional for properties. Leaving them out makes the attribute that the property describes into a read-only attribute. Properties simplify the construction of descriptors for a common case, but there are cases where we could use a descriptor that property can't handle well. For example, what if we were planning on making a class that represented remote data, and we wanted its attributes to push and pull data from the remote source? We could do that with properties, but we'd end up writing the very similar code over and over, implementing each attribute. It would be better to have a remote resource descriptor class, and just add a bunch of instances to our local stub class. Let's go ahead and do that as an example. Actually interacting with the network requires a fair amount of code, so it's a good thing we can avoid repeating it over and over. The remote resource class we have here has double underboard get, set, and delete methods, which determine what happens when an attribute that is controlled by an instance of this class is accessed. The get method, perhaps surprisingly, takes two parameters: the instance through which the attribute is being accessed, and the class through which the attribute is being accessed. It's like that so we can handle both instance attribute access and class attribute access. When accessing a class attribute, the instance parameter is none. In our case, we just return the descriptor itself if somebody tries to access the attribute as a member of the class instead of as an instance member, which is a reasonable default in a lot of cases. The set method is passed an instance and a value, and conceptually represents setting the controlled attribute for that instance to that value. Unlike get, it doesn't have support for setting a class attribute, so instance will never be none, and we don't need a class parameter. The delete method is just passed an instance, and represents removing the controlled attribute from that instance. Notice that none of the descriptor methods are told which attribute they represent. The assumption is that their self-parameter will, one way or another, specify that. In our code here, we've chosen to pass the necessary information into the descriptor's constructor and store it as an attribute of self. But in other circumstances, we might use self or self's ID as a key into a dictionary stored in the instances to store per instance state for the descriptor, or use the instance as a key into a dictionary stored in the self. We can't just store per instance data as attributes of self, though. The descriptors are attributes of the class, not the instance, so their values are shared by all instances of the class that contain them. Once we have the remote resource class, creating classes that have remote attributes becomes easy, as demonstrated by our record class here at the end. So descriptors override the semantics of accessing a particular member variable. For many uses, the property decorator, along with the setter and deleter subdecorators, provide all the functionality that we need. We can also define descriptors as objects, giving them double underscored get, set, and delete methods. Descriptors are themselves, however, are attributes of a class, not of the instances of the class, even though they override the access to instance variables. There's a lot of room for creating interesting descriptors, but we've covered everything you need to know to start working with them. In the next section, we'll cover unit testing.